This section will cover the terminology and location of components. Behind the operator's cab contains the fuel tank with a capacity of 106 gallons and optional auxiliary fuel transfer pump and the power switch for the transfer pump. The switch will only work when the main key switch is in the on position. Above the fuel tank is the standard air conditioner evaporator. Next is the hydraulic tank with sight glass to visually check the hydraulic oil level and has a capacity of 171.7 gallons. The tank has the pump case drain filter, the free fall brake coolant line filter, and the control line oil filter secured to the outside of it for good accessibility. The inside of the tank contains 2 pump suction filters and 2 return oil filters. Next is the main power divider with a visual oil level check sight glass that is used to drive the 3 Kawasaki main hydraulic pumps, free fall coolant pump, and primary control pump. These pumps are secured to the power divider and allow adequate spacing for routine maintenance. The next area contains a Hino 11-liter engine that produces 363 horsepower that meets interim 4 emission standards. The engine oil level dipstick is easily reached, and the fuel and oil filters are easily reached with drain plugs to catch the fluid securely before removal, and the fuel transfer priming pump is also easily reached. This area is lined with sound dampening material to reduce engine noise. This connector is used to connect the handheld control box that operates the counterweight lifting and removal and the gantry control. Located below is the connector that is used to hook the handheld controller when operating the translifters or the hydraulic track frame securing pins. Under this cover, above the engine compartment, is the part of the Hino diesel particulate active reductive system, which is referred to as the DPR system. This muffler-type component contains the DOC, or diesel oxidizing catalyst, and the DPF, or diesel particulate filter. During operations, the DOC will be used to assist in actively burning off the trapped particulates in the filter to reduce emissions and maintain peak engine performance. Next, we have the engine coolant radiator, engine fuel cooler, engine air after cooler, and the hydraulic oil cooler. We have removable side panels to assist in the external cleaning of these coolers. Above the coolers, we have the main engine air filter and the access panel to add water and engine oil as required. Now, starting from the front center of the machine, we have the hydraulic actuated main boom base foot pins. We also have the quick connect couplers for the optional third hoist. Below these covers, there are 2 Kawasaki swing motors and 2 swing reduction units that can produce up to 2 revolutions per minute. There are 2 smaller covers that can be quickly moved to access the swing reduction unit oil levels. Mounted to the front area of these covers is the junction panel that's used to connect the attachment harness, and during the self-removal configuration, using the mast only, the angle sensor for the mast will connect here. Now the front and rear hoist drums are visible and sometimes referred to as the main drum and auxiliary drum. They both have a rated line pull of 29,700 pounds and maximum line pull of 52,500 pounds on the first layer by using 26 mm wire rope driven by a variable displacement Kawasaki hydraulic motor through a gear reduction unit. Both drums can produce up to 361 feet per minute of line speed with the standard hydraulic mode winch assemblies, and with the optional free-fall winch assemblies, the speed can be increased in the lowering direction only. Also, the braking can be controlled by foot-operated pedals with the free fall option that actuate oil-cooled, low-maintenance brakes. The standard brakes are integrated into the hoist motors and are oil-cooled and are both controlled by the operator lever. Both drums have mechanically operated drum locks that are used for securing the drums. In the rear of the machine, we have a double boom hoist drum driven by a Kawasaki hoist motor through a gear reduction unit and stopped by internal low-maintenance oil-cooled brakes. These drums contain 26 mm wire rope and can produce line speeds up to 72 feet per minute. These drums also have an external mechanically controlled drum lock used for securing the drum. This is the mast, and at the base we have the mast assist arms. These are used for stowing or raising the mast before or after transport. At the upper tip, it is equipped with sheaves that have sealed bearings that have grease fittings. Under normal operation, these bearings require greasing every 1,000 hours, or under heavy-duty applications, require greasing every 500 hours. The gantry has the same type sheaves and requires the same grease interval. It also contains the load weighing pin. On the left side of the machine behind the top cover, we have the front and rear winch motors and gear reduction units with oil level sight glasses. These are situated for easy access. Below the winch motors behind the bottom cover are the pilot control valves. Behind the first door are some of the main control valves and boom hoist motor. The next area contains the auxiliary hydraulic oil cooler and two 12-volt batteries hooked in series to supply 24 volts of power to the machine. On the back of the upper portion of the machine is the rear counterweight assembly. This assembly has 14 counterweight pieces, each weighing 11,900 pounds. The weights are stacked in 2 stacks of 7, referred to as B, your left counterweights, and C, your right counterweights. These counterweights are placed on a counterweight base, which is referred to as the A counterweight, weighing 34,300 pounds. When all 15 pieces are combined, the total upper counterweights are 235,200 pounds. Located on both the front and rear of the lower machine are the car body weights, weighing 18,300 pounds each, and a B or C counterweight piece that weighs 11,900 pounds. These are secured to the top of the car body weight. We also have the 4 translifters used to support the machine when removing or installing the 51,800-pound crawler frames. We have 2 bubble levels mounted to the car body frame as an aid to keep the machine level. The crawler frames on the CK2750G are held in place with 2 hydraulically controlled pins and 2 fixed pins. The hydraulic hoses with quick connects for operating the translifters or the track connecting pins are stored in the center of both sides of the base machine. The crawler frame assemblies feature track rollers that are oil sealed and do not require greasing. The track pads have arrows cast in them to indicate the forward direction of the tracks visually from the operator's cabin to quickly remind the operator the direction the crawlers are facing. The track tension is adjusted and maintained behind an access panel using a hydraulic jack and fixed shims that maintain position of the oil-sealed front idler wheel assembly. The rear of the crawler frame contains the propel motor, propel gear reduction unit, and drive sprocket that move the fully assembled machine at 0.62 miles per hour. The complete propel assemblies are narrower than the track pads, and this aids in the prevention of damage to the assemblies from unseen obstacles during movement of the machine. The oil level in the reduction unit can be checked periodically by removing one plug and changed by removing the lower plug every 1,000 hours.